Hello, let's take a look at lesson 333, day 2. We're looking at the associative and commutative properties again today. In our first problem that I'd like to work through with you, we have a person named Juno, and Juno is working on simplifying the expression 24 plus 3 plus -4 plus 7. I know, he exclaimed, it must be equal to 30 because 20 plus 10 equals 30. And our question is Juno correct? To start this problem, I went ahead and I copied the original problem down again. And then I used order of operations and I started solving it with my left to right progression because the only parentheses that I have around anything in this expression would be around the -4, and that's just to separate it from the operation sign versus the number sign. So when I do this math, I end up getting 24 plus 3 equals 27. Bring down my -4, bring down my 7. Then I work the next step. 27 plus -4 gives me 23 plus 7, and I end up with 30. So yes, Juno is correct. And our next question to analyze is what did Juno do to get 20 and 10? And I look back up in my problem here, and when I'm looking up here, I see, or I can look here, if I combine these two, I know I get 27. If I combine 24 and -4, that should give me 20. And then if I combine 3 and 7, I would get the 10. And that's what I've written out here for us. And there we have our answer is 30 again. So it did not matter how I grouped those numbers. Let's take a look at a question that we have, a clarifying question right now. And we have, does the commutative property work for other operations? In other words, does order matter? And I went ahead and I have put down some problems for us to kind of explore this situation and this idea with. 7 plus 5, I get 12. 5 plus 7, I still get 12. 7 times 5, I know is 35. 5 times 7 is still 35. Now I'm moving on to subtraction. So these are both yeses. So the commutative property does work for those two operations. 7 subtract 5, I get 2. And 5 subtract 7, well, I have to go towards 0 and beyond. So I'm going to end up at -2. These do not equal, so this is a no, no. So commutative property does not work for subtraction, and the order does matter. This one here, if I do 10 divided by 5, I get 2. 5 divided by 10, I get the reciprocal of 2. Well, I could start out by saying 5/10, which I can reduce or simplify down to 1/2, which is the reciprocal of 2. This number and this number do not match. So division is also not working with commutative property. Okay, so now we have another property to think about. And that property is the associative property. And let's see if we can get this moved down a little bit so we can see what I have for us, what I prepared for us. Okay, so does the associative property work for other operations? Here I have addition, and I would do what's in the parentheses first. So this is 12 plus 9 gives me 21. Here I do what's in parentheses first, and I do 5 plus 9 gives me 14, plus 7 still gives me 21, even though they're grouped differently. So this is a yes. Multiplication, I would do 3 times 2 gives me 6. 6 times 4 gives me 24. And I can write this out and put that in a different number here. 6 times 4, and I end up at 24. This one here is 2 times 4 is 8, and 3 outside of a parentheses means I multiply. 3 times 8 is also 24. So that is a yes as well. So both multiplication and addition, I have proved there with my examples. Let's take a look at subtraction. Let's see what happens here. The 7 subtract 5 is 2. 2 subtract 1 is 1. Over here, I need to do 5 subtract 1, that's 4. 7 subtract 4 is 3. So that's a no, because they do not match. And division, I've got 10 divided by 2 is 5. Divided by 5 equals 1. 2 divided by 5 is 2/5. And 10 divided by 2/5 gets rewritten as 10 multiplied by the reciprocal. Well, that's pretty weird. So that doesn't work. So division is not associative. Division is not commutative. Subtraction is not commutative. Subtraction is not associative.